Analysis of sorting algorithms.
Good day everyone! Today, I'm going to discuss analysis of sorting algorithm. First, what is algorithm? Algorithm is a step-by-step process of a specific problem that aims to explain the whole concept of the solution itself. Next, what is sorting? Sorting is about arranging data in a particular format. Importance of sorting algorithm. Data searching can be optimized to a very high level if data is stored in a sorted manner. For readability of data, real-life example, contacts in telephones and dictionary. How can we say that contacts in telephone and dictionary are considered as example of sorting algorithm? Because these two examples are using concept of arrangement in alphabetized manner. Terminologies to note. Increasing order, a sequence of a value wherein the successive element is greater than the previous one. Example, 1, 3, 5, 7, 9. Decreasing order, a sequence of value wherein the successive element is less than the previous one. Example, 12, 8, 7, 5. Non-increasing order, a sequence of value wherein the successive element is less than or equal to its previous element in the sequence. Example, 12, 7, 5, 5, 3. Non-decreasing order, a sequence of value wherein the successive element is greater than or equal to its previous element in the sequence. Example, 2, 6, 6, 9, 10. Stable sorting is the term being used if the sorting algorithm after sorting its element does not change. If the elements are similar, on the other hand, not stable sorting is those elements that changes the sequence of similar content which they appear. Adaptive sorting algorithm. It is that during the sorting process, if there are elements already in the proper place, adaptive algorithms will try not to touch any of it or try to resort it. Non-adaptive sorting algorithm is the opposite of the adaptive. It tries to force every single element to reorder to confirm if the element is sorted or not. First example is bubble sort algorithm. This is a simplest sorting algorithm, a comparison-based algorithm where each pair of the adjacent element is compared. If the elements are not on its proper position or not in order, then that comparison will be swapped. So let's proceed to the example of bubble sort and how it works. We assign an assorted array for the example of bubble sort. Bubble sort compared the first two elements to check which one is greater. If bubble sort determine which one is greater, the third element will be compared to the second element to be able to know which one is greater. We find that the third element is less than the second element, so that these two must be swapped. The next array should look like this. Then we will compare the third and fourth element to know which one is greater, and we find that both elements are in the right place. As we compare the fourth and last element, we know that 10 and 35 is not sorted, hence they must be swapped. Then the value will goes by until you obtain the sorted array. This second example of sorting algorithm is insertion sort. This is a in-place comparison-based sorting algorithm. A sublist is maintained which is always sorted. A sublist is always sorted. Inserting an element there will find its appropriate place and insert it there. Process. Array is searched sequentially and unsorted items are moved and inserted into sorted sublist. Now, let's proceed to the example of insertion sort. Also, we created an unsorted array. And also, insertion sort compares the first two elements and we find that first and two elements are in the right position. Insertion sort compares the second and third element and it finds that second element is not in correct position, so it must be swapped. It will check with all the elements of sorted sublist. Here, we only have one sorted sublist and we determine that the second and first element is in the right place. By now, we have 14 and 27 in the sorted sublist. Then we will compare the third and fourth element. We find out that these values are not in sorted order. So, we swap them, but as we swapping 27 and 10, we also find that 27 and 10 is an unsorted order. So we swap them too. Then process goes until all the sorted values are covered in sorted sublist. The third sorting algorithm is quicksort. This sorting algorithm uses the idea of divide and conquer. It finds the element called pivot, which divide array into two halves, in such a way that elements in the left half is smaller than pivot, and elements in the right are greater than pivot. We recursively perform three steps. First, bring the pivot to its appropriate position such that left of the pivot is smaller and right is greater. Second, quick sort left. Third, quick sort the right part. The second to the last is radic sort. This sorting algorithm is only used for the sorting of numbers. We sort the numbers from least significant digit to most significant digit. We use counting sort as a subroutine to sort. The fourth example of sorting algorithm is merge sort. Its sorting technique is based on divide and conquer technique. The process, it divides the array into equal halves and then combines them in a sorted manner. This is one of the most respected algorithms. To understand merge sort, here is the example. We created an assorted array and we know that merge sort divides the whole array into halves. As we can see, the array of 8 items is divided into two arrays of size 4. This division will not affect the sequence of the appearance of the elements in the original. And now, let's divide these two arrays into halves. Then divide the elements until we achieve the atomic value. Now, let's bring back in its previous order. We first compare the element for each list and then combine them into another list in sorted manner. As we can see, 14 and 13 are in sorted order. We compare 27 and 10. And in the target list of two values, we put 10 first, followed by 27. We change the order of 19 and 35. But 42 and 44 is still the same. In the next combining phase, we compared list of two data values and merged them into a list of found data values placing, all in sorted order. After final merging and combining, the list should look like this. The fifth example is heap sort, a special case of balanced binary tree data structure. The root node is compared with its children and arranged accordingly. If A has a child node B, then key of A is greater than or equal to key of B. Two types of heap sort: min heap and max heap. First, min heap. Node's value is less than or equal to either of its children. Max heap. Root node's value is greater than or equal to either of its children. Consider this an unsorted array for the example of heap sort. 4, 10, 3, 5, 1. Then build a heap. And now that we have built a heap, we need to transform it into a max heap. Create a max heap. In a max heap, parent node is always greater than or equal to its child nodes. 10 is already largest. 10 is greater than 4. So we swap 10 and 4. 5 is greater than 4. So we swap 5 and 4. Then swap the last and first node and remove the last node from the heap. And also, create again another max heap. And as we all know, in max heap, parent node is always greater than or equal to child nodes. So 4 and 1 will swap. And swap again the first and last node, then remove the last node. Then create again another max heap. Then repeat the process of swapping and removing until we reach the assorted array. And this is the process of heap sort algorithm. The sixth sorting algorithm is counting sort, a sorting technique based on keys between a specific range. Count the number of objects having distinct values. It involves some arithmetic operation to know the place or the position of your values. This is only suitable for direct use in situations where the variation in keys is not significantly greater than the number of items. The sixth sorting algorithm is counting sort, a sorting technique based on keys between a specific range. Count the number of objects having distinct values. It involves some arithmetic operation to know the place or the position of your values. This is only suitable for direct use in situations where the variation in keys is not significantly greater than the number of items. For the example of counting sort algorithm, consider data in range of 0 to 9. Create a count array to store the count of each unique object. Initially, the count of all elements is 0. Count each element in the given array and place the amount at appropriate index. Next, modify the count array by adding the previous counts. And since we have 7 input, we create an array with 7 places. Corresponding values represent the places in the array count. We place the objects in their right position and decrease the count by 1. And this is the sorted array using counting sort algorithm. The second to the last is radix sort. This algorithm is only used to sort numbers. We sort number from least significant digit to most significant digit. We use counting sort as a subroutine to sort. Consider this an unsorted array for the example of radix sort algorithm. First, consider the ones placed. And this is the order when you base on the ones place of each element, but observe that 170 has come before 90. This is because it appeared before the original list. And next, consider the tens place. And this is the order when you base on the tens place of each element. And lastly, consider the 100s placed. As you can see, the elements are in sorted position. And this is the example of the radix sort algorithm. The last sorting algorithm is bucket sort. This sorting algorithm creates buckets and put elements into them. Apply sorting algorithm like insertion sort for sorting elements in each bucket. Consider this array. We have total of 10 elements, so we create 10 buckets. Element 78 to bucket 7, element 17 to bucket 1, element 39 to bucket 3, element 26 to bucket 2, element 72 to bucket 7, element 94 to bucket 9, element 21 to bucket 2, element 12 to bucket 1, element 23 to bucket 2, element 68 to bucket 6. As you can see, in this example, the first digit of the element is the basis where the bucket they are suitable. And now, let's sort each bucket individually using the insertion sort. And this is the final output of sorted array using bucket sort algorithm. And that's the end of our discussion. I hope you learned something in this video. Thank you for watching.